Okay, so in this session, as I'm sure you're all aware, we're going to be talking about Swift and C interop. When Swift first came out, there was a lot of talk about how Swift and Objective-C were interoperable, and you can kind of understand that from Apple's point of view because everybody had an existing Objective-C code base and they wanted people to adopt Swift, so the best way that they could do that was to sort of incrementally adopt it rather than asking everybody to rewrite their entire code base. So there's lots of stuff, lots of coverage about Objective-C and Swift interop. Not really so much about vanilla C, but there are many use cases why you might end up working with C, so I think this is a valid topic to cover. So in this session, we're going to review what's easy and what's not so easy. We're going to take a look at some of the common C paradigms and then how they translate to Swift. We're going to cover some of the caveats that you're going to stumble upon if you find yourself working with C from Swift, and then how to work around those. And we're going to do a brief crash course in C, so things like pointers. It is very brief. So just before we get started, show of hands, anybody worked with C in the past? Hopefully, yeah, great, that's good. So we'll just brush over all the stuff about pointers then, and we'll get straight to the good stuff. So the first thing you're probably thinking, we all work with Swift, and Swift was pitched as Objective-C without the C. So now why are we all in a room wanting to work with C? But there are many reasons, as I said, that you might find yourself working with C. A lot of the core frameworks Apple provides are in fact written in C, mainly for performance reasons. Some of these you will be probably familiar with. Some of you that maybe don't have a C background might have been working with these and not even realizing that you were working with C. So obviously a big one, core graphics. Cortex is another big one. I found myself working with Cortex for the majority of the summer last year. Prior to Swift 2, when C interop was a lot better in Swift 2 than it was in Swift 1.2. So we'll talk about that a bit later. But there are a lot of open source projects that are written in C that you might find yourself wanting to use as well. So we've got libgit2, which powers the GitHub for Mac app. So anybody that uses that, that's what's underneath interacting with Git. We've got Mongoose, which is this yellow logo here. That's an embedded HTTP server. That's quite a niche requirement, but it is a good example of an open source C library. And again, performance reasons. We've got the common Markdown parser. Pretty much any Markdown parser you come across, right at the bottom, if you get to the lowest level, will be written in C, again, for performance reasons. And then we've got SQLite, which is what we're going to be using through the rest of this session. And that actually comes as part of the iOS SDK, because SQLite underpins core data on iOS. So, okay, we now know, we've established that we might sometimes need to work with C from Swift. So let's look at some of the problems. Why is it a difficult topic? Or why are there hurdles that we need to overcome when we want to work with C from Swift? Well, to start with, they're very different languages. C is a procedural language. Everything exists in the global scope. It's not object-oriented, it's not protocol-oriented. Whereas Swift, on the other side, multi-paradigm, it's got all those stuff. It's great, it's really rich. C gives us low-level access to the memory. You can do whatever we want. We've got malloc, we've got free. It's up to the programmer to manage all that. Swift, no direct access to memory via pointers or anything like that. I've put a star at the end because, as you'll see as we work through the sessions, that's not strictly true, but in the context of this table, it's relevant. C is pass by value, whereas Swift is pass by reference and pass by value, depending on whether you're using structs or classes. Again, I've put a star here because C has pointers, and pointers allow you to simulate pass by reference. Manual memory management, just touched on that. Anybody that's familiar with free will be familiar with malloc and free. But with Swift, we inherited automatic reference counting from Objective-C. C has weakly enforced types. Obviously, Swift is a very safe language, so they enforce type safety across the board. So then all these things make C inherently unsafe. That's not to mean that you shouldn't use it. It just means that you should sort of tread carefully, whereas Swift is safe by design. And that's probably the most, that's what we should focus on, and that's where a lot of the issues come from when we're trying to work with C from Swift. And this has nothing to do with the rest of this table, but we wanted to put this in. Obviously, you can name things in Swift using emoji, but obviously there's no emoji in C. So, quick crash course, as I said. All this will be really familiar with anybody that's done any C programming. But we're going to cover pointers, because pointers are sort of the biggest topic we're going to cover throughout the rest of the session. And a pointer is a sort of type of object that stores the memory address of another object. And this was important in C, because back when C was a mainstream language, memory and CPU weren't as liberal as they are today. So rather, it was a much cheaper operation to pass around the memory address of an object rather than copying the object, because remember C is passed by value. So anytime you pass an object to a function and it's not a pointer, then it will be copied. Well, pointers are copied anyway, but we'll get into that in a minute. So we've got an example here of some C code for anybody that's not familiar with C. We set up our number, which is of an int, and we set that to 5, and then we set up a pointer. We set that to null, so we've got our null pointer. We then use the ampersand to say we want our pointer to point to the memory address of number. And then when we reuse the sort of multiplication sign, that's called dereferencing, and that allows us, rather than to access the memory address of the pointer, to access the value or the object that memory address itself references. So this allows us to print the value, in which case that would print 5. We can then again dereference a pointer and set the value to 25. This will change the original variable, so both these things print 25. If we then look at pointers in Swift, and we take the same example, Swift doesn't give us direct access to pointers. It gives us a struct that wraps a pointer, and these make full use of generics. So we can use types. So again, we create our number, 5. We then create a pointer. Because we want to change this number, we use unsafe mutable pointer. If it was a constant, we would just use unsafe pointer, but we'll look at that in a minute. We allocate the memory of one instance of an int, which is what that last bit means. We then initialize the pointer with our variable, which is number, it has a value of 5. And then we access the memory of the pointer using this memory property. And that's how we get like the dereferencing. So again, in the same example, we then change the memory to 25. But there's a subtle difference, you'll notice. If we print the original number, it prints 5. But then the dereference memory prints 25. And this is because we're now trying to write C using, rather than just interacting with some existing C, we're trying to write C. And it follows the same language semantics as Swift. So when we pass number, because number is a struct rather than a class, it's copied. So when we change it, it's changing the copy rather than the original value, which is why that's different. So again, pointers in Swift, this is just an example function that's declared in SQLite. And that's what we're going to be looking at later. When Swift imports it, it looks more like this. As you can see, we've got a constant, so it's imported as an unsafe pointer. Strings, or C strings in Swift, come in as an 8 or uint 8, and we'll talk about that a bit more shortly. And then the next one, this is interesting. It's a pointer to a pointer, so that comes in as a mutable pointer, because obviously we want to be able to change that. And then we've got this other pointer type, which is C opaque pointer. And again, we'll talk about what a C opaque pointer is in a moment. So the first thing, pointers to pointers. Why have we got that double multiplication sign? Again, anybody familiar with C or has written C, worked with C libraries will know what this is all about. But for those of you that don't, it's all again to do with passing by value rather than passing by reference. A lot of the way that a lot of C libraries are written is that you initialize a null pointer and then you pass that into a function. And that function will create the object and update your pointer to point at that object as a way of being able to manipulate more than one sort of return value, if you like, from that function. So if we just create our null pointer, which has got a memory address, and pass that in on its own to this function, that will then take a copy, which would have a different memory address than our original one. And then that function would update the copy rather than the original one. So instead what we do is we create a pointer that points to that pointer. If you remember, pointers just point to the memory address of another object. So that's why they can point to other pointers. Because that then holds the memory address of the original pointer, we can pass that in. It will be copied, but the original memory address will go with it, and then that function can do the dereferencing, creating the object, and updating the original pointer. So that's why we use pointers to pointers. Opaque pointers, that was the other unusual type. So if we look in the header for SQLite, you'll see this typedef struct, SQLite 3, SQLite 3. This is what's called like a forward declaration, and it's basically a incomplete declaration of a struct called SQLite 3. And it's a contract between the developer and the compiler that as long as somewhere else in the code base they provide the complete implementation, then that will satisfy the compiler, and the compiler will allow you to do this. And it's a good way to hide away the implementation of a type that perhaps you want to allow a consumer of your API to use, but not necessarily know too much about the implementation. So what Swift does is, when it's importing the C code so you can use it from Swift, it needs to be able to determine what the members of that struct would look like, so all these kind of things here. But because we only import the header file, or that's all that's made public, Swift can't determine what those members are, so then anything that it can't determine becomes a C opaque pointer. Something else I wanted to quickly look at was C strings in Swift. Obviously, we can go two ways. If we take a Swift string and we want to use that in a C function, Swift will take care of the conversion for us, no problem. And that's what we can see here. We've got our let file name equals Swift string, and then we pass that in, and we don't have to do anything else. Coming the other way, if we want to, if we get given a C string and we want to convert that into a Swift string, then there are a few hoops we need to jump through. Sometimes Swift will bring a char or a C string in as a uint8. Sometimes it will bring it in as an int8. Because of that, and I've not quite got to the bottom of why that would be, Swift has this cchar type alias, but it doesn't allow you to use it like mix and match. So this call to SQLite 3 column text actually returns uint8, but because there's this differentiation between sometimes things come through as int8, sometimes things come through as uint8, we then have to convert it into a cchar, which is Swift's internal type for chars, and then we can pass that into the string, the Swift string initializer that takes a C string, and then give it the encoding type. Return codes, this is just a touch on some common design patterns in C libraries, and again, we'll get into this as we start working with the SQLite 3 library. Because everything's function-based, it's procedural in C, if you want to know whether the operation that function carried out was successful, it's a common design pattern to return a return code from a function, and it allows you to do things like update or return multiple values in a single call, and also know that all those values were updated successfully without having to look and check for each one. It's equivalent to using the in-out annotation in Swift. And you can see there at the top, we're using this guard statement. This is actually a call through to the C library, but we're still using guard, and we'll touch on this because obviously using C within Swift, we can take advantage of some of the better Swift language features. But we're comparing it to SQLite _OK. Now, in the C code base, that's a simple define macro. Swift doesn't import C macros apart from simple define ones, and then it will import them as global constants, which is why we can do that comparison. And finally, I just wanted to touch on why we're going to be using SQLite. Well, SQLite is a fantastic library. It's self-contained, serverless, zero configuration database for anybody that's not used it before. It's open source, and even though it was released back in 2000, it's still regularly updated. It's included in the iOS SDK. As I said, it kind of underpins core data on iOS. So when we were working with the demo, there's no messing about trying to hook up any third-party dependencies. It's got a really good, extensive, well-documented C API, and we're going to take full advantage of that as we get into the demos. And it's blisteringly fast. This is really good. I was concerned when I put the demos together for this session. I wanted to keep everything as simple as possible, so we're going to be loading quite a lot of data out of a SQLite database. And I was thinking about throwing that on a background thread and dispatching a sync in it and all that kind of stuff. And I wanted to keep everything as simple as possible. So we're going to do everything in view.did_load. But then I was worried that we were going to be like stalling a made thread, and like the experience. I want to move through this as quickly as possible because we've got a lot to cover. I didn't want anything to hinder that. Turns out, didn't need to worry because SQLite is incredibly fast. So, and then with that, we can get straight into the first demo. You've all got the session materials. So if you find the demo 1 starter project for this session, copy it to your desktop and then open it up in Xcode, and then we can get stuck in. Okay, so we're going to do a little bit of role playing. Imagine that we work for a client, and our clients come to us and they said, okay, so I've got this app, and it's almost complete. All the interface is done. All I need you to do is take this SQLite database I've got and populate this table view with the data that's in this SQLite database. But as many big companies do, we don't want you to use a third-party dependency, so we can't turn to something like FMDB. We've got to use the raw C API. So that's the kind of context we're going to be working with this afternoon. So if we sort of just build and run this app to start with, you'll see that the app itself is pretty much, let's just make that a bit bigger. Sorry about that, just wait for the simulator to boot. So if you run that, you'll see that we do have what's he doing? It's got a tiny screen, so we can't use the 6+, I'm afraid. There we go. So this is our app. As I said, the custom cells that we're going to use, they're all set up. The whole interface is set up. All we need to do is open our database, extract some data, populate this table view, and then we should be good to go. So if we stop that, and we're just going to, we're going to do everything, as I said, in view.did_load. So if we open subscribe as view controller, and the first thing we want to do is, in the class itself, implement view.did_load. And then just make sure we call through to super. And then at the very bottom of view.did_load, we want to make sure that we reload our table view, because we are going to do all our code, so that will be the last thing that we do. We're going to sort of work between these two statements. Right, so anywhere in that method, just start typing SQL, and you'll see that we get all the SQL functions that come up that are part of the C API. This is done because, I did forget to mention, there are 2 ways to import C code into a Swift project. You can use a module map, or you can use a bridging header. For this option, I chose to use a bridging header because as I said, the SQLite is included as part of the SDK, so it was the easiest thing to do. So we've got this bridging header set up here that simply imports or includes the SQLite 3 library, which is why we get all those functions pop up when we start working. So if we go back and we just we start typing SQLite, and we want to look for the SQLite 3_open method, because the first thing we want to do is open our database. So you want that first one there. And as you can see, I mean, that's quite cryptic. Like, if we hadn't have had a look at what those pointer types are like on the slides, it's like, okay, so what's going on here? As I said before, the header files and the C API for SQLite are really well documented. So if we option click on SQLite 3_open, we can actually see the definition for that function. And it's much easier to read than that code that Swift imported for us, and you're going to find that a lot. So if you start working with a C library, hopefully it will have a really well documented header file like we've got here, and it's a lot easier to decipher what we need to be passing in, that kind of stuff, than just looking at the standard Swift code. So we can see that that we need to pass in a file name, and this is a constant, and then we've got to pass in one of these pointer to a pointer. But you'll also know that we're using that SQLite 3, that opaque pointer, so we can't actually instantiate an instance of unsafe pointer or unsafe mutable pointer and use generics, because Swift can't understand what the implementation looks like, so we've got to use a COPake pointer for that. So if we jump back to subscriber view controller, just delete that for a minute because we're going to re-implement it properly shortly. So the first thing that we want to do is we want to create a pointer that we're going to use that we're going to pass in to that function, and that function will then open the database, populate that pointer for us, and then we can use that pointer moving forward with any other functions for SQLite. So we'll just declare that now. We'll call it database. And again, we're going to be using COPake pointer because Swift can't determine the type that we need to use. And then the other thing that function needed was it needed the file name to the database itself. So again, we're going to take advantage of, even though we're working with Swift, we can take advantage of some of the Swift, working with C, we're going to take advantage of some of the Swift language features, and the first one's going to be guard. And we're going to get the file name using nsbundle, because the database is already bundled with the app. So we'll do main bundle, and then we're going to do path for resource, and the name is subscribers, and it's of type SQLite without the dot. And then we're going to call that function that we just took a look at the definition of. And again, we're going to wrap that in a guard statement. If I can spell guard. There we go. Oh, OK, yeah, sorry. Else we're going to just simply return from that. OK, yeah, sorry. There we go. You see that? Yeah. So then we're going to call that method we just looked at, and we're going to pass in our file name. And then remember, this is a pointer to a pointer, and so far we've only got the single pointer. We can use some shorthand here, and we use the ampersand, and then we pass in database, and that's shorthand for pointer to pointer, and Swift and C will take care of the rest for us. We're going to compare that to that imported global of SQLite OK. And then if it's not that, we're just going to, again, return. So if we get past this guard statement, then we know we've got an open database. So we're just going to make sure we do that by printing to the console. And just to show you how Swift imports those constants, we can also click on those, and you can see these are what it looks like in the header file. And then if we is it alt-click? Yeah, there we go. You can see it imports it as a global constant of the type int32, which is what we talked about on the slides. So the last thing that we need to do is we need to make sure that we've now got the database open, but we need to make sure that before we leave view.did_load, we want to close that, because we want to be a good citizen, make sure we always clean up after ourselves. And again, we're going to take advantage of another Swift language feature, even though we're working with a C API. We're going to add a defer block just below here. And then in that defer block, we're going to use SQLite 3 close. And again, we're just going to pass in the pointer we've got to our database. And then just to make sure that's happening, we're going to do another print statement. Database close this time. So if we build and run now, all being well, we should be able to have a look at the console and see those two messages. There we go. So it looks like everything's working. We've got our open message, and then because of our defer block, when we exit the current scope, that'll be called close the database, and then we print to the console. So we can stop that running now. So we've got our database. It's open. We've got a pointer to it, so we can now use it. The next thing that we want to do is we want to run some SQL to extract some data that we can then use to populate our table view. So just below the defer block, just start typing SQLite 3 _ p, and we're looking for prepare. And OK, so this one's a little bit more cryptic than the one we had before. So again, you can see how this is going to start playing out now. The easiest way to try and understand what's going on here, sometimes you get the kind of parameter names, sometimes you don't even get those. We've been lucky this time, is to, again, option click on the function name, and that'll give us the definition. Then we can actually start seeing what it is we need to pass in. So this is the way that you run a SQL statement with SQLite is it actually prepares it, which converts it to bytecode and then executes it against a database, and then holds the results. So what we're going to do is we're going to pass in our database. We're going to pass in the SQL statement. The next one, the maximum length of the SQL, it's an odd one. I don't understand why anybody would want to use this, but basically it's saying only use n number of characters from my SQL statement. So we're just going to pass in -1, which means use the entire SQL statement. We're going to pass in another pointer to another forward declaration. This time it's SQLite _3 statement. This is what's going to hold the results. So then we can interrogate that and get the results out. And this last one, again, is another pointer to a pointer. If you actually passed in a length other than the full length of the SQL statement, this would give you the remaining string that it didn't use. But again, we're not going to use that this time. So if we jump back to subscribers view controller, we'll just delete that because the implementation is slightly different. So we need a statement. So if we come back up to where we've defined database, and we're going to now define statement. If I can spell, there we go. And again, that's going to be a C-opaque pointer because we can't determine what the underlying members of that type are. And then just below the defer block, we're going to add our SQL statement. So this is a SQL that we're going to execute against the database. It's dead simple. We've just got one table in the database, and we're just going to select 3 fields from it. So it's name, card underscore type. Oh, it's 4 fields actually. Card underscore number, card underscore expiry, and then it's from subscribers, which is our single table. And now we've got our SQL statement. We need to then prepare it using that function that we just looked at. And again, we're going to wrap this in a guard statement. So we're going to do SQLite 3 prepare. OK, so now, even though it's cryptic, we understand the kind of things that we need to be passing in. The first parameter is database. The second one is our SQL statement. So we've got that there. We're going to pass -1 here because we want SQLite to use the entire SQL statement. Again, we're going to make use of the ampersand because this is a pointer to a pointer, and we want to be able to access what that function populates in our statement. So we're going to ampersand statement. And then we can just pass nil for that final one because we don't want to worry about anything that's not used. And if that fails, oh, hang on, we need to check that against SQLite OK. SQLite OK, rather. And if that fails, then we'll simply return again. So one thing we always have to make sure of, I'm not sure it's a bug because it's well documented, but once you finish with a prepared statement, you need to get rid of it, otherwise it causes memory leaks within SQLite. And we need to do that before we close the database anyway. So we're going to add another call to the top of our defer block, which will get rid of that prepared statement before it attempts to close the database. So we just need to add in SQLite 3 finalize, which is the way that we dispose of that prepared statement. And again, we'll just pass in statement for that. So we've opened our database, and now we've got our prepared statement. And assuming this works and we get past this guard statement, we'll then have some results that we can now process and populate our table view with. So the first thing that we need to know is we're going to do some iteration now using while loops and whatnot. So we need to know how the number of columns in that SQL statement. We know it's 4 because we can see the SQL statement, but we just want to make sure that's the case, that's what's returned. So we're gonna let me just put that at the top. We're going to create a new constant and called number of columns. And then we just need to convert the result of this next function we're going to call to an int, because we're going to use it in a minute. And it's SQLite 3 underscore column count that we're looking for. And then we pass in our prepared statement, which is just statement. And that'll give us the number of columns that are in that statement. And now we've got that number, we can now step over each of the rows in that prepared statement, and then we can iterate over the columns and extract the values. So we're going to use a while loop for that. So underneath there, we're going to do while SQLite, another call, SQLite 3 step. And we're going to pass in the statement. And we're going to say where that's equal to SQLite underscore row. And then we've got our while loop. Now, basically what's happening here, within the sort of internals of that prepared statement, there's a cursor. And each time we call the step, it moves the cursor to the next row and returns SQLite row. When it gets to the last row and there are no more rows, it will return SQLite OK, at which point we will then exit that while loop. So now we've got our rows, and we know the number of columns. We can now iterate over those columns. But we need somewhere to store the values we're going to extract from those columns as well. So we're just going to set up an array called values, and that's going to be an array of strings. And then we're going to iterate over those columns. So it's for column and 0 to the number of columns. And now we're in a row, and now we're in each of the 4 columns that are in that row. We need to extract the text value. Now we're just going to extract the text value because I know I prepared the SQLite database that all those 4 columns are text. In the real world, you'd want to do some introspection on the column type to make sure that you were extracting the right type of value. But we don't need to worry about this for the sake of this demo. So we're going to start by extracting the C string, and then we'll do some conversion. Excuse me. So we'll call this raw text, and we'll use another SQLite function to get that. So it's SQLite 3 column text. And we need to pass in the pointer to our statement, and then the column number. And obviously, this is why we're iterating over the columns. So that'll give us the text value for that particular column. Oh yeah, sorry, my bad. There we go. And now what we need to do is we need to cast that to that internal Swift cchar type. So we're going to create another one called cstring. And this is going to be an unsafe pointer, because we're not going to change it, so it doesn't need to be mutable. And we're going to make that of the type cchar, and then we're going to initialize it with that raw text. And that'll give us a pointer that we can then pass to the Swift string initializer that's looking for a C string. So again, we're going to use guard. So it's guard let value equals string. And we want to use a C string initializer, that one. And we're going to pass in our C string pointer, and then we want to use the UTF-8 encoding. So it's NSUT. There we go, at the bottom. And then if that fails, we just want to break that current iteration of the loop. So if that succeeds and we get a value, then we can now append that value to our values array. And now, once we've finished with all 4 of our columns, we want to now use those 4 text values to instantiate an instance of our model class, which I meant to touch on earlier, but we have a model class called subscriber, and it's just got the properties, or the same sort of properties that are in that SQL statement. It just takes an array and does initializes that, and that's what we're going to use to populate the table view. So that needs to make sure before we do that we have actually got all 4 values. So we're just going to do another quick guard to make sure that the count of values is equal to 4, or equal to the number of columns rather, which would be 4. And then if that's not the case, then we just want to ignore that one and continue on with our loop. And now we can initialize an instance of our subscriber model class. So guard let subscriber equals subscriber.fromArray, use that shorthand method, we're passing the values array. And if that fails, we want to continue with the next iteration. And now right at the beginning, we already had set up this subscribers array, so we're just going to append that subscriber to our subscribers array. And because we already added the code to reload the table, if we build and run now, hopefully we should, there we go. So we see we've got all our subscriber details populated. So that's the first demo complete, and hopefully you can see that once you sort of start understanding some of the ways that Swift and C interoperate, and how we can still take advantage of some of the Swift language features, it starts to become a little bit easier when trying to work with C from Swift. Now, I've still got a lot to cover, so we're probably not going to have a break, but has anybody got any questions before we move on? Go on, Alexis. OK, Vicky, have you got a mic?
Question?
Alexis.
I was just wondering about the string interop. Like, what is it that allows us to pass a Swift string in where it's asking for an unsafe pointer int 8? Is there a constructor or something?
No, Swift just takes care of that for you under the hood. I mean, I've not really looked at the internal since they open sourced it, but it's probably just doing something like that, where there's an initializer that takes that. But yeah, I mean, unfortunately, it doesn't work the other way, because it'd be much easier if it did. But yeah, going from Swift to C works really well. I think there was another one, Vicky. Somebody else have the hand up?
Question?
No? OK. Oh.
Come in.
So when I was first playing around with Swift and C interoperations, I was playing around with frameworks like Core Audio. And one of the issues I ran into almost instantaneously was big endian and little endian conversions. A lot of the error codes, when you go down to low-level frameworks, consist of chars that are reversed in bit size, and then you have to convert them and switch them and assign them to characters when they're ints and vice versa. I was just wondering what your experience with that has been.
I've had no experience with that. So unfortunately, I can't shed any light on that. But I would expect, was it Swift 2 or Swift 1.2 that you were working with
at the given time, I think it was 1.2.
OK.
Swift 2, I briefly played with it at the beginning. 2.1, I haven't touched it.
OK, because the interop through each version gets a lot better. Like, the stuff that I was working with in the summer last year was all 1.2, and it was just a complete nightmare.
Yes.
And then rewriting a lot of that stuff in Swift 2 and 2.1 is far easier. Like, the stuff that we've done in that demo would have been it would have been far more code just to get to where we've got now. So it'd be worth giving that another go and seeing if that's something else that the Swift guys have looked to see if they can handle automatically, that conversion.
And just out of curiosity, later in the presentation, are you going to go through striding at all information?
No, so it is something I was going to mention at the end, rather than using size of, use stride, yeah. I mean, we can talk about that now, if you want.
It's just something that I'd like to see somebody actually do in real-world scenarios. I've seen sample code for it, and I've seen other stuff. And it seems to be very useful when dealing with C arrays.
OK. Well, come see me afterwards then, because it's not something that we actually cover. But we can have a chat about it afterwards.
OK.
Anyone else?
Any more questions before we move on?
Are we doing for time, Vicky?
We're pretty good, but we should move on to.
OK, yeah, no problem. Let me just get the next slide deck up there. OK, so in this second part of the session, what we're going to look at is something that had me tearing my hair out working with 1.2, which was function pointers. that had no support whatsoever for function pointers. You had to do all this sort of hacking with the Objective-C runtime to wrap your Swift code in an Objective-C block, because you could pass an Objective-C block as a function pointer, and it was just a bit hacky and horrible. But luckily in Swift 2, they implemented some support, and we'll look at what I mean by that as we work through this next part. So for those that have never used function pointers, what is a function pointer? Well, as the name implies, it's simply a pointer that points to a function. Because if you remember from the beginning, a pointer is simply stores the memory address of some other object or type, and when your code runs, a function will have a memory address, so we can have a pointer that will point to that function. We've got an example at the top here. We've got our centimeters to inches function, and here on this line we create a function pointer to it. It matches the original declaration apart from this first pair of curly braces. And what we put in there is the name of that function pointer. And then we can use that throughout the rest of our code to call the original function using that name that we put in those parentheses. Primarily, these are used as callbacks. And that's what we're going to get into in a moment. We can pass a function pointer to a C function that expects a function pointer, and it will call that function pointer back at the appropriate time. But interestingly enough, and we're not going to cover this in the session, but it was just something I stumbled across and found it really interesting, is that you can actually use function pointers to simulate classes and objects in C. I have a feeling some of this might be under the hood in Objective-C, but there's plenty of information on the internet that you can read more about that if that's something that you might be interested in. So function pointers in Swift, as I said, these are new to Swift 2. They are imported either as, well, they're imported as a closure definition with the calling convention. I don't know if you've seen these calling conventions before, but Swift will annotate certain things with a calling convention, and that informs the compiler some specific rules around how that can be used. In order to use a function pointer from Swift, we can either use a global Swift function, so something that's declared in the global scope, or an anonymous closure. Those are the only two things that can be passed as a C function pointer. But what that means is, well, it's obvious from the first bit, but not so much from the second bit, that you can't capture any values or any context from the enclosing scope. Obviously, if you declare it in the global scope, there's nothing to capture anyway other than other global things. But if you're passing a closure, like the way that we would use closures normally in Swift is that we can pass, it will capture context, and we can use that context or those values from within that closure itself. You can't do that when using function pointers in Swift. There are ways to get around that, which is what we're going to look at in a moment. So this is how we get around that. But I'm going to give you an example because it's much easier to explain with an example. So assume we've got our object, and for the purposes of this exercise, that's our view controller. And our view controller registers a callback to be used by our C library. And at some point, we're probably going to want to be able to access properties and methods of our view controller from within our closure that we're using as our callback. But because we've got that calling convention and it can't capture any values from the enclosing scope, we can't, there's no relationship between those two things. So the way that we get around this is we create a pointer to that object. And when we register the callback with the C library, we pass that pointer. This is another common C programming sort of design pattern or paradigm. You will often find that any C function that expects a function pointer to be used as a callback will also have like a void pointer, which is a pointer to anything, where you can pass in some arbitrary data that you want to then be passed back to the callback. So we pass that pointer to our object into the C library when we're registering our callback. That holds onto it. When it calls our callback, it passes the pointer into the callback. We can then dereference that pointer and access the properties and methods on our original object. So that's the way that we get around those restrictions that are enforced by that convention, that calling convention. So that's what we're going to do now. We're going to go straight into demo 2 and look at function pointers in practice in Swift. So this demo picks up from where the previous one left off, but if you didn't follow along or you missed a step or whatever, there is another sample, another starter project for demo 2 that you can use. So you probably noticed that when we ran the app at the end of the previous demo, it looked like credit card data, and that's pretty much what it is. But this is bad practice. This is bad form. You don't want to expose the entire credit card number for all your subscribers in your app. So what we're going to do, a common thing to do would be to mask the first 12 characters of a 16-digit credit card number. So that's what we're going to do now. And we're going to look at the Swift way of doing it, and then we're going to look at doing it via SQLite at the SQL level using function pointers. So the first thing we're going to do is, if we scroll down to the bottom, you'll see that we've already got a extension on our view controller that provides this masked method that takes a credit card number, and it's a really naive implementation. I don't don't use this in the real world. It makes a lot of assumptions, but that's okay because we're in a demo and I know what the data is like. But we basically just strip out the first 12 characters and replace them with X, which is a common practice to do. So we're just going to update our code to do that the Swift way, and then we'll look at using SQLite to do that. So where we've got our values append line there, we're just going to comment that out, and we're just going to use the ternary operator. So we're still going to append a value, values rather, dot append. But we're going to check to see if our column number is equal to 2, which is actually the third column, which is our credit card number column. And if it is, then we're going to call that masked method, and we'll pass in value. Otherwise, we'll just return the value. And if we build and run, you see that now we have a masked credit card number. Okay. So we could leave it here. That's fine. It's still unsafe, obviously, because the raw data is there. But that you could leave it there and walk away. But instead, what we're going to do is we're going to look at something that's pretty cool as part of SQLite. SQLite doesn't allow you to create internal SQL functions like a lot of the other SQL databases do. But what it does allow you to do is register a custom function that you can call as part of your SQL statement, but you pass it a function pointer, and then as it's processing that SQL at the database level, once it's got the values, it will call that function pointer, and then you can operate on that data, pass it back. When you finish operating to SQLite, then it will be returned as part of your prepared statement. So that's what we're going to do now. So just below the defer group here, let's just start typing SQLite 3 underscore, and we're looking for create function. And again, like the most cryptic one yet. I mean, this is crazy stuff. But because we've got that really, really good header that's well documented, if we option click on SQLite create function, then we can start understanding what some of this stuff is. Now, instead of having the dots at the side like the previous one, like if we scroll up, like this is all the documentation for that single function call. So we're not going to go through it all now. But what this is basically doing, it's going to take our database. It's going to take a name that we want to call that function at the SQL level. We're going to tell it how many arguments that function takes. If that function deals with text, then we need to tell it what that representation is. So we're going to use UTF-8. And then we've got this PAT, which we'll come back to later. And then these are the 3 callbacks that we can take. And again, these are the function pointers. Now, if we're going to be doing a specific type of function, SQL function, so it's not an aggregate one. If it was an aggregate one, we need to use these final 2. But because we're doing a Scala one, so it just one value is passed in, we operate on it, pass one value back. And then that's returned as part of the results. We only need to use the first, or pass a function pointer to the first one. We can pass nil to the remaining 2. So if we return back now to subscribe as view controller, we're gonna attempt to implement that. So start by deleting that because our implementation again will be slightly different. As I mentioned in the slides, we can either use a closure or a global function. In this demo, we're going to use a global function, and then in the lab, you'll see how to use a closure. I wanted to make sure we did both. So if we scroll right to the very top, above the class, we're going to create our global function, and we're going to use it's got to match that signature that we just seen, that xfunc parameter, the function pointer signature. So we'll call this func callback, and it passes in a context, which is a COPake pointer, a count, which is the number. So we say, OK, this is going to take one argument, and the count will tell us that OK, it's passed in one argument, and then, or the number of arguments, but in our case it'll be one, and then we passed in the arguments, which is an array, and then we can extract what we're looking for. So arguments, and this is unsafe mutable pointer, and again, it's a C opaque pointer type. And that doesn't return anything, so it's just void. So the first thing we want to do is we want to make sure that this is actually being called when we expect it to be called. So we're just going to put in a print statement, and then we'll flesh out, we'll actually do the actual processing of that data in a little while. So it's print, and then we're just going to put in the custom function. And then, so basically how this works is SQLite is going to pass us the value of the column of which we call this custom function on, and we can do whatever we want with that, and then we have to pass the result back to SQLite. So in this implementation right now, because we just want to see that being printed to console, we're just going to pass back straight the value that's passed to us, because we're not going to do any process on it just yet. So I'm just going to type this out. I won't explain it because we're going to delete it shortly. But all we do is call, oh, we need the SQLite 3, result, text, we pass in the context that we're given. Just going to do unsafe pointer. Because it's it's text, so it comes through as a char, we just need to cast it to a unsafe pointer. And then we're going to do SQLite 3 value text, and this is the function that extracts it from that array. So we're going to use arguments, and it's 0, 1, 2, 3, and then we want -1 for that, and nil. I've got an extra closing bracket there, sorry. So now we've got our custom function. It's not doing much at the minute. It's just going to print and then return the result that SQLite passed us in Swift. So we actually now need to register that, and we're going to use that really cryptic function that we just took a look at. We need to register it before we actually run the statement, so we're going to do it here just below the defer block. And again, we're going to use guard. So guard SQLite 3 underscore create function. We're going to pass in our database pointer, and we're going to call this function masked to match the one that we've got in our view controller. It's only going to take one argument, which is the value of the column that it's being called on. It is text, so we're going to use UTF-8, but this time, because we're doing it in SQLite, we need to use their constant for UTF-8. We're just going to pass nil for that one, and then the next one is our callback. So we're just going to pass the name of our global function there, which was callback. And then we can pass nil for the final two, because that's for when we will be doing aggregate rather than scalar operations. And then we want to check that against SQLite OK again, and if that fails, then we're just going to return. So if we build and run now, the other thing that we need to do is update our SQL statement to actually call that function. So on the card number, we're just going to wrap that in a call to masked, like so. And then if we build and run, we see that if we have a look at the console down here, our database is opened. Then we are in the custom function for every row in that result set. I think it's about 200 rows. And then we close the database. So now that we know that that's working, we've registered this custom function at the SQL level. SQLite is calling our callback using a function pointer. We can actually now implement, like give that a proper implementation. So we just delete the contents that we've added there, and we can add in our proper implementation. The first thing we need to do is we're expecting a single input argument. That's how many arguments we told SQLite to pass us, but we do want to check for that. So we're just going to use guard again. And we're going to check that that's 1. And if it's not, then the two things we need to do, usually we would just return, but we need to inform SQLite that there's been a problem. So we just do SQLite 3 result null, pass in the context, and then we can return. So if that succeeds, we then want to get our string, our C string, out of the arguments array, and then pass that to the masked method on our view controller. So we're going to get the C string to start with. This is a bit hairy, so try and keep like if you can't see anything, I'll do my best to help you if you get stuck, because there's lots of code in here with weird pointers. Unsafe mutable pointer, and we've got to type it to the char again. The internal Swift type. I'm going to do SQLite 3. Oh, don't want that one. SQLite 3 value text. And then we're going to pass in the arguments, and we want the first value. And again, then we want we can use the NSUTF this time, because we're pulling it out. And then if that fails, there we go. Then we need to do the same as we did above. We need to return a null result. So we'll pass in our context, and then we return. OK, so we've done our check to make sure we've got a single argument coming into this function. We then extract our C string and convert it to a Swift string. So now we can pass this to our method on our view controller. But we're in the global scope, and there's no relationship between these two things. It doesn't know it's not aware of the instance of subscriber's view controller. So this is where we need to now look at that passing arbitrary data. If we jump back down to where we register the SQLite create function and command click on it again, you'll see that there's this void pointer to p-app. And if we scroll up and just look through and find this one here, this is the one that allows us to pass the arbitrary pointer. And then once we're inside the callback, we can use SQLite 3 underscore user underscore data to get a handle on that pointer. So if we pass a pointer to the object we want to use within that function as a fifth parameter, and then use SQLite 3 underscore user data, we can get that back within the callback, and then we can start calling methods and properties on our view controller, including that masked one. So that's what we're going to do now. So if we jump back to subscriber's view controller, if you remember, the first thing that we need to do is to create a pointer to our view controller, or self, which is obviously what self points to, is this instance of our view controller. Now, there are two ways to do that. We can, just like in C, we can create a pointer and manage the memory manually using some stuff that's similar to malloc and free. Or Swift actually gives us some functions that you can say, OK, give me a pointer for this object, and it will then give you a closure. And as a parameter to that closure is the pointer. But that pointer only exists for the scope of that closure. So as soon as you exit the scope of that closure, that pointer is thrown away. And so the memory for that is all managed by Swift. We're going to look at the manual approach now. And then in the lab, you'll see how to use the sort of more Swift approach, if you like. So we're going to create a pointer to our view controller. And we're just going to do that above where we create the function. I'm going to call it pointer. And we're going to create an unsafe mutable pointer. And because obviously we can use generics, we can type this to our subscriber view controller. If I can spell, there we go. And then we need to allocate one instance of that in memory, so it's alloc1. And now we need to initialize that pointer. Oh, subscribers view controller, sorry. Now we need to initialize that pointer, so we'll do pointer dot initialize, pass in self. Now, because obviously we talked on this right early on, because this is a class rather than a struct, it's not going to be copied. It'll be passed by reference, and that's how we get that access in the callback. And now we've got that pointer, we can actually pass that pointer as a fifth parameter. So we just change that nil value there to pointer. So now we're passing our arbitrary data into our callback, or it will be passed in by SQLite. But again, we wouldn't need to be a good citizen. We need to make sure we clean up after ourselves. So we're going to add another defer block just after where we create our function. And all we're going to do here is dealloc that pointer. And because we've only got one instance at the top, we're just passing one instance there, and it'll just dealloc that straight away for us, and we don't need to worry about that. So now we've got that, we can carry on with our implementation of our callback function. So the first thing we want to do now is extract that user data out using that SQLite 3_user data function. So we'll go let user data equals SQLite 3_user data. We'll pass in the context. And now we want to make sure that we need to create a pointer now that is typed to our subscriber view controller so we can actually access the properties and methods of that. So we're going to create another pointer. We'll call that pointer again. And this time it's unsafe pointer typed to subscribers. I can't spell that. There we go. Subscribers view controller. And then we initialize that with the user data. And now we can call our masked method, and we can pass in the value string that we've got there. And the way that you access the original instance is through the memory again, like we saw on the slides. And now you see that we've got our all the stuff that's accessible on our view controller instance, including our custom masked method. So we're just going to pass in value. And now, actually, we need to make sure we get the return value from that. There we go. So now we've got our masked credit card number. We now need to then pass that back to SQLite. So we're just going to do guard result equals. We first need to convert it to a C string. There we go. If that fails, we need to do that same cleanup that we were doing before. Result null, pass in the context, and then we can return. And then if that works, we can finally pass that back to SQLite. So it's SQLite result text. We'll pass in our context. So this next parameter here is expecting our C string. Now we have got a little bit of a problem here. If we look at result and we look at what type that is, it's that cchar type. Now cchar underneath is uint8, but this method is expecting an int8. And the easiest way that I found to get around this is to just use string duplication function from the C library, which just duplicates the string, because that returns int8 rather than uint8. So that's what we're going to use now. String dupe, and we just. Pardon? Oh yeah, sorry. There we go. Can you see that? And we'll pass in our result there, and we just need to pass -1 for that one, which is saying use everything. It's a string, use everything, and then null finally. And that's now passing our duplicated string back to SQLite for further processing. So now we can actually plumb all this together and see it all being used. So the first thing we need to do is go back to where we commented out that statement, that one, and we can comment out the new one and uncomment the original one. So we're no longer calling masked from within our instance of our view controller. It's going to be called from within our callback. And then we just need to build and run. And you'll see that we've still got our masked credit card number, but this is being masked at the SQL level by using our callback, which is passed as a function pointer. So that's the end of the second demo. I'm conscious of time. I do want you to get as much through the lab as possible, because what you do in the lab is, obviously this all still has a strong whiff of C about it, even though a lot of it's written in Swift. So what we do is we refactor all this out in the lab and we wrap it in a really Swift-like wrapper. So if you've got any questions, like if there's nobody with any questions, great. If you have got any questions, it might be worth just coming and see me after the session's finished, so to give you as much time to work through the lab as possible. Okay, great. Everybody crack on with the lab then. Okay, guys, that's all the time we've got for the lab. So we're just going to wrap this up, and then you can take a short break before we get into the inspiration talks. So what did we learn? Well, we started off discussing a few of the reasons why you might find yourself working with C from Swift in the first place. We then took a brief tour of pointers to pointers, opaque pointers, and what part they have to play in C and then in working with C from Swift. We also reviewed converting C strings to and from C, as well as the sort of return code design paradigm that's used in a lot of C libraries. And then when you put all that into practice in the first demo, where we opened up a SQLite database and we ran some SQL against it, and we processed the results and populated a table view, all using the C API. Well, then in the second section, we looked at function pointers and how Swift deals with them, what the limitations are, how we work around those limitations, and then, on that last point, how we can pass data around to sort of work around at least part of that limitation. We then went into the second demo where you applied that knowledge and we registered that custom callback function from SQLite. And then finally in the lab, hopefully if you were able to work through it, you took all that knowledge and you wrapped it all in a really nice Swift wrapper, which kind of hides away any sort of C interaction anyway. But as always, there's more to learn. Can't recommend this book enough, Advanced Swift by the obc.io guys. That's got 2 chapters on C and Swift interop. They are really good chapters. I learned a lot last summer, and they've been updating that book. I don't think it's actually been properly released yet. It's still going through the betas, and it was early access, and they've refined that from 1.2. It helped me last summer, and again through 2 and 2.1. One of the authors, Chris Idoff, did a talk on Swift and C at PragmaConf. That video is online. You can find it on YouTube. These, if you've got the PDF, are actually clickable links as well, so that should take you straight to that video. Definitely watch that if this topic is something that has interested you. There is some documentation. It's really bad, but it does have a couple of snippets in it that are quite useful, so do check that out. Again, this is linked. If you want to see how far, like that wrapper that you did in the lab, right at the bottom on the where to go from here section of that, it tells you all these kind of things how you would then take that on to the next step. If you want to see how far you can go wrapping SQLite or a C library into Swift, check this out, SQLite.swift by Stephen Chellis. It's on GitHub, it's open source, it's fantastic, and some of the inspiration of what I did today came from this library. I'm around for the rest of the conference. If you've got any questions, do come and see me, or you can get me on Twitter or on the Slack channel if you're on Slack. Thanks, everybody, for coming, and I'll hand you back to Andrea now.